Hi, welcome. I'm Brendan Burns. I am the Director of Engineering for Azure Container Service. I'm here with a couple other people who will be on later on. Gabe Monroy, who is newly from our acquisition of Deis. I don't know how many people saw that in the news, but we're really excited to have them join us. He'll be talking a little bit later on, as well as Yob from GitLab will be on stage in a little bit. But I'm here to talk about containers and the Azure Container Service, and effectively how containers can transform development and operations. So I always like to start this out with a little bit of a show of hands, just kind of get a sense for the audience. So how many people here have played around with containers in some way or another? I'm going to say that's 80%, maybe, something around there. OK. How many people have deployed containers to production? All right, that's about 10%, I'm going to say. How many people have done something sort of in between? Have something in like test, canary, pre-production? All right. How many people believe they'll have something in production, let's say, in the next year? All right. Oh, wow. Cool. All right. Well, thank you. It always just helps me, get a sense for where we're at in this whole world and the cycle that we're going through. I really profoundly believe that this is one of the really profound changes in computing that we're going to go through, similar to cloud, similar to object-oriented programming, and really, I think the first truly cloud-native moment that we're going through. So that's pretty cool. So hopefully, throughout the talk, I'll give you a sense for what that looks like and why you should be interested. So I'm going to start a little bit, bring everybody sort of up to the same speed. Hopefully it's not too redundant. We're going to start with my thoughts on what a container is, build up to what we think a container orchestrator is, what a container service is on top of a container orchestrator, talk a little bit about how containers change operations, as well as orchestration and how I think it's going to have an impact on how we build software into the future, as well as I think maybe a few sketches from the future about what the world might look like. Along the way, we'll have some live demos. So if you're here for the carnage, we will not disappoint, I hope. Anyway, sadly, I do have video backups, so it won't be that embarrassing for me if things fail. All right, cool. Well, what is a container? A container is an application packaging and deployment mechanism, right? This is not the only thing that a container is, but this is one of the primary things that reasons that people come to use containers is that, simply put, it's way too hard to deploy software if you deploy software using imperative scripts that run at startup or at deploy time. They fail in a myriad of different ways, in ways you don't expect, and they always fail while you're in the middle of a critical deployment to fix a bug that is affecting production, right? So containers enable you with the container image to take everything that you need for your application, wrap it up, and deploy it in a single package. And in particular, one of the things that this packaging and deployment mechanism means is that where previously you may have had dependencies on a single shared library that span two different containers, when you start packaging up these applications into their own hermetically sealed container, the shared library actually moves into the container itself. So really, the line between the operating system and the application becomes much clearer, much cleaner, and much simpler to manage. And this means that it's much easier to deploy multiple applications onto the same machine and not have them interfere with each other. So you may have been in situations where somebody wanted to upgrade a particular library that was shared between multiple processes, but someone else said, no, you can't update that library because I depend on version 1 and version 2 has bugs. And now suddenly it becomes a real big discussion about, like, do we upgrade to version 2 for this application over here, or do we stay on version 1 because this application hasn't been updated yet? With containers and with pushing things into that container, suddenly those questions go away. You've decoupled these teams from one another. They can build, update, push their software independently of one another. Your application deployment process has become significantly more modular, significantly more agile. All right. Additionally, a container is a packaging distribution mechanism, right? Once you have an image, that's great. You built it in a CI/CD system. You built it on your laptop. But you need to get that out to the world. Azure is in 38 regions around the world. How do you take that thing that you built on your laptop, that thing that you built in our CI/CD system, and push it out to all those different regions? There's lots of different ways that you could do it. But it turns out that having this container registry, like Azure Container Registry, having this notion that there is an API that you can use to push your binary artifacts around the world Just makes it significantly easier, one less thing you need to think about, right? You take your laptop, you build that image, you can push it up to a registry, you can run it inside of a container orchestrator, run it anywhere. And definitely, if you haven't already have the chance to take a look at Azure Container Registry, which is our solution in this space, please do go check it out. It really simplifies a lot of these, going from an image that you know works to an image that you know works everywhere. All right, what else is a container? Well, it becomes a clear boundary for your stuff, right? There's a relatively famous quote that says, fences make good neighbors, effectively, right? Having this boundary around that defines what your thing is suddenly makes you think about, like, what is in my application and what is not in my application. I would argue that one of the things that object-oriented programs did was give you that notion of a class. And in the notion of a class, you suddenly had to think about, like, conceptually what should be in my class and what should be outside of my class. Typically, when you deploy onto a machine, you're going to have a bunch of different stuff. You're going to have a web server, you're going to have monitoring agents, you may have an SSH daemon, RDP daemon, log roller. They're all kind of mushed up together. There's no clear boundaries necessarily of team ownership, of deployment, anything else like that. If instead you start deploying these things as containers, suddenly we start seeing, oh, that's my web server container. I've drawn a boundary around what that thing is. I can say, this team owns that thing. That's my SSH daemon. That's something that needs to go everywhere, regardless of application. There's an operations team that owns that. And then, oh, that's my monitoring container. It's got log rollers. It's got monitoring agents. That's something that the operations team or a specialized monitoring team can own and deploy. So suddenly, instead of a bunch of different pieces on a machine where ownership lines aren't clear, where deployment boundaries aren't necessarily clear, by having this clear boundary around things, you do a better job of organizing the stuff that you already have. So that's another thing that a container really does for you. And finally, and I think this is where containers started, but interestingly enough is not why they're mostly been adopted in sort of the popular cloud, the container becomes a runtime isolation environment, right? And this means then that you can run a production web service and some intern's Minecraft server on the same machine safely, right? It's important to note that this is not a security boundary, right? We still need hypervisors in order to establish multi-tenant security. But if you're within a single trust boundary, you can have resource isolation. You don't have to worry about someone else's use of memory clobbering your application's use of memory. You don't have to worry about someone else's use of CPU clobbering your application's use of CPU. This is really powerful because, of course, this means we can pack applications together and still have reasonably good guarantees that they're going to operate with the SLAs that we expect. Right? So although mostly I think people come into containers for some of the benefits of packaging and organization and deployment, at the end of the day, runtime isolation is the thing that allows you to reduce your cost of operations, to run your applications more densely, and ultimately at a lower cost. But as long as we're talking about running things, it turns out that how many people run their applications on a single machine? Oh, I saw someone almost raise their hand. It's OK. You can admit it. It's a friendly audience. Nobody runs their applications on a single machine. Failure domains, scale, all these sorts of things. I actually remember back when I started programming, we did run things on one machine. And we paid a lot of money for that machine so that it never failed. And it still failed, right? And so we've reached a place where that's not the way that you build and deploy applications. We need systems, we need APIs that allow us to deploy our systems to multiple machines, in some ways to even forget about machines. And that's where the container orchestrator comes in. The very first thing that a container orchestrator is doing is it's trying to take a homogeneous fleet of machines and turn it into a single entity that you can manage, right? And that's really what Azure Container Service and the open source container orchestration APIs that we use within that service provide, right? They take a group of machines, you forget about the machines, they give you a unified API surface that you can communicate with, where you can come and say, hey, here's my container. Here's that application image that I built. I want you to run it somewhere, right? When you double-click on a program that's on a laptop, I mean, at this point, every single laptop that we have has multiple cores, right? When you double-click on a program to run it on a laptop, you don't select a core that you want to run it on, right? You've delegated that to the operating system. You said, find a good place for it. Run it somewhere. And that's what you're doing with this container orchestration API. You're saying, you know what? I've given you 10 VMs. run this thing somewhere, or maybe run lots of copies of this thing somewhere. Right? And that's, again, the power of abstracting yourself away from a machine and focusing in on this artifact that is dedicated to your application. All right. And then in addition to this, this provides this really strong opportunity to standardize application support services. Right? So it's not just, I mean, I said how many people run their programs on a single machine. How many people just run a single program with no restart loop out in production? Right? Programs crash. You have to have something there that's going to restart it if it crashes. You have to have some daemon there that's going to monitor that application. You have to have some unified way of making sure that you don't run out of disk space with all your log files. Right? Prior to containers and container orchestration, this became something where you had to have a checklist, or you had to have some way of establishing the best practices for deploying your application. Suddenly, in the advent of this containerized world where we're abstracted from the machines, an operator or a cluster admin can come in and place log rollers on every single machine that you inherit simply by the virtue of the fact that you're using this container abstraction API. Right? So suddenly, and all of the container orchestrators that we use provide APIs for doing automatic restart of failed processes, for doing automatic migration if a machine happens to fail. Right? So all of a sudden, all of these support services that had to be sort of learned by, the hard way by failures or by an operations team going through a checklist before you could launch are behaviors that you get simply by deploying into this container orchestration surface. And that's hugely powerful. It allows you to collaborate, build best-of-breed solutions for your company and for your environment, deploy them once, and have them work for every single application that you ever deploy. Right? So that homogenization of the operations is another thing that this container orchestrator API provides for you. And then the last piece of this is as something that I actually realized I mentioned already, which is it also gives you an environment where you can deploy daemons that you want to be running, little support services that you want to be running, something like intrusion detection, something like some other sort of scanning that you're doing on your machines. You can use the container orchestration system to do that as well. Right? So this substrate isn't just something for deploying your applications. It actually becomes the exact same interface that you can use to push everything onto the machines that you need to run. And those things, too, can be packaged into containers by your teams, can be rolled out in a safe and scalable way. All of the things that you were getting from your applications, you can get from the agents that you need to run on each machine as well. And again, this really radically simplifies your ability to successfully manage applications in the cloud at scale. And this slide is redundant. All right. And then finally, this API also becomes a target for a CI/CD, right? Which is continuous integration, continuous delivery. Sorry. By the fact that we now have this application-oriented API, we have an interface that we can plug into upstream systems, right? When you had to deploy a virtual machine, there is no API really with a virtual machine for deploying your application, right? You have startup scripts, you have things to do, but it's not really an application-oriented API. It's more like a byproduct of the machine that you happen to create. And that makes it much, much more difficult to plug in a continuous delivery system that knows how to go from Git to a built container image to an image that is deployed out in the world. And as we'll see with GitLab later on, this container-oriented API suddenly provides a really simple way of interfacing upstream systems that push out your application with the place where your application runs, with the container image as the sort of abstraction layer that lives between them. All right. So we've covered now what a container is, and we have covered as well what a container orchestrator is. So then Azure Container Service. What is Azure Container Service? Well, really the job of Azure Container Service is to make all of this stuff easier. Right? So you may have seen earlier the announcement of Postgres availability inside of Azure. Right? So that's a Postgres service that we run for you. We make running Postgres easier. Now, at the end of the day, when you interface with that database, you interface with Postgres using the Postgres API. The same thing is true with the Azure Container Service. We have a service here. It's going to run these container orchestrators for you, deploy and scale and otherwise manage these container orchestrators for you. The API you use is that same open source API that you use if you deployed it yourself. It's just easier if you use this thing as a service. Right? And so that's the real role of a container service, is to take all of the complexity around deploying and managing one of these container orchestrators and simplify it for you. All right. So you call into the container service API. The container service API creates the container orchestrator for you. And when that's all done, you communicate directly with the existing API for that open source tool, which means the whole ecosystem of tools that exist out there for interacting with the container orchestrator, all of the CI/CD pipelines, all of the monitoring pipelines, pretty GUIs, all of this stuff just work because the API is the same API that you may run on-premise, in a private cloud, or anywhere else, right? So you get this consistency of experience while having the ease of use of a managed service. All right, so this is the first opportunity for things to go wrong. I want to show you just how easy it is to turn up an ACS cluster. All right, so we'll drop over here. My laptop will hopefully wake up. There we go. You all guessed my pin from the dots, right? OK. So here we are, and so I want to show you how in a couple of different commands, we can actually create a running Kubernetes cluster. So I can say, this is the first, and this is actually running live. I don't type because I make horrible mistakes, but it is actually going out to Azure right now and creating a resource group in the East US data center. And now we're going to actually go and we're going to create the Kubernetes cluster. All right. So this is the command. It's saying, hey, in that resource group that you just created, please create me a Kubernetes cluster. And what it's doing in the background is it's provisioning some AAD credentials that it's going to use. Kubernetes knows how to create load balancers for you, knows how to mount disks. It actually takes a couple of minutes for the cluster to actually spin up. It's spinning up 4 virtual machines. So we're going to actually jump back to the presentation, and we'll come back in just a second when that's done. So while we're waiting for that cluster to create, I wanted to take a step back and say how to actually, I've hopefully sort of described to you containers and the motivations for using containers and container orchestrators, but how does this actually change the operations that you do on a day-to-day basis? So practically every talk that I've ever given has a version of this slide in it. And the reason that it has a version of this slide in it is I think it really captures the job of being an operator really well. Both because it has a jackknife semi and also because it really illustrates the problem. In my experience, most outages are self-inflicted. So what does this mean if most outages are self-inflicted? Does it mean that we're all horrible people who like to wake up in the middle of the night? No. It means that our systems are too complicated. It means we don't necessarily know how the impacts that were of a change in one part of the system affect some other part of the system. And the classic example of this is backing up a tractor trailer or backing up a boat, right? Physics says I'm backing this up this direction, but if your trailer's at the wrong angle, it's going in a different direction than the way you're backing up. It's horribly non-intuitive, and anyone who's done this knows it takes some time to get used to. Right? And it's because you have this coupling between the tractor and the trailer. So what we really want to do is decouple our systems from one another. If we can break our systems apart so that motion over here doesn't affect something else over here, suddenly a lot of those outages that were self-inflicted go away because we have a good understanding of what we're doing in our little local space. It's just we didn't understand how that change was going to impact something somewhere else. And this is part of what we're doing with containers, container orchestration, and container services. Right? So we want to decouple operations, or SRE, into a bunch of different layers. Right? And starting at the bottom, you have something like hardware SRE. These are people who are in a data center physically adding and removing machines. Now, if you're in the cloud and you're using IaaS, you've already decoupled yourself from this. Right? Azure virtual machines are already taking care of that for you. So you've already basically broken all the rest of your SRE off from your hardware SRE. But you can keep going upward, right? We can actually say, you know what? We can opt out of kernel SRE, or we can build up a team that knows how to do operating system SRE. We can build up teams that know how to do all of these different levels. I think that people talk a lot about DevOps, and I think it's actually, DevOps meant, I think at some point, that developers were supposed to own the whole stack, or that's how it turned out. I think this is actually what it really meant, was that DevOps were supposed to own the application part of it, the part where the developers actually understood. That doesn't mean that I, as an application owner, should be rolling out new kernels. Trust me, it's a very bad idea for me to be rolling out kernels. Likewise, it's probably a bad idea for that operating systems person to be rolling out a new version of my application. We have to decouple these problems from one another, and that's what containers and container orchestrators can do for you. It turns out cluster SRE is actually also DevOps because the cluster is just another application that you happen to be running. But you can have a separate team that knows how to manage the cluster application and a team that knows how to manage your application, right? So we have this notion that Azure Virtual Machines decouple you from hardware SRE. Container runtimes and images kind of decouple you from operating system. They enable you, because your application is no longer deeply tied to your operating system, you are able to have a team that upgrades the OS without necessarily even talking to the people who deploy their application on top of that operating system. You have cluster SRE, where you can actually use something like Azure Container Service, just like you used that IaaS layer. You can step up and say, you know what, we're going to use the Azure Container Service layer, and I'm actually going to be decoupled from all of that stuff. I don't want to be bothered. I'm going to have this container orchestration API. But I do have bad news for you. It turns out that you still own your application. Right? There's nobody who's going to operate that until you sort of step up to a platform as a service layer, and that could actually even be run by your team or by the cloud as well. All right, so we're going to go back to our demo, and I want to show how this actually happens in practice, how an operation that you do can work. So I'm going to go back over here. This button, 8. OK. So now I'm going to be using Kubernetes as a cluster orchestration API to do a rolling update while we're under load. So with luck, this will work. All right, so this is my service. In Kubernetes, we have the notion of a service, which is a load-balanced thing that knows how to talk to multiple replicas of a service. Here's this definition. It's a declarative definition. You don't really need to worry about very much of it, except for it's running on port 80 with the TCP protocol. All right, I'm going to go ahead and create that. I'm going to deploy version 1 of my application. So here I've deployed, you can see right here, I'm actually just deploying a container image. It's BusyBox. It's a very simple container image. And I'm going to, while true, I'm going to echo version 1 into a data file and serve that out. All right. So now I've created it. It's out there running in my container orchestrator. So again, the orchestrator created by Azure Container Service is sitting out there in space. I don't really know anything about it except for the API. I have a command line series of tools that enable me to talk to it. If I go looking around in my project, I'll see virtual machines, I'll see load balancers. But really, from my perspective as an application owner, don't need to worry about it. All right, so now, this is not going to work. Yes. I had my path set up separately somewhere else. This is the first blood in the water that you get to see. All right, I'll kill this out. Go back over here where my path is actually, set up correctly. Sorry about that. You get to see a little bit of the behind the scenes. All right, so I'm actually going back in and I'm deleting the things that I just created so that I recreate my demo state so that it doesn't freak out when. This is why you can see now why I don't actually type my demos usually. All right, so let's go back. All right, so now go through there. That's the service before. Let's create that service. Let's create v1 of our deployment. Let's create. It is, valuable to note how easy it is for me to then go and, all right, now we got that going on. So I'm actually what I'm doing here is you can see over here I have 5 instances of my application running. I'm actually going to load up a web browser, not a web browser, but curl in the loop here. It's looping with v1. You can see it's hitting a bunch of different replicas. v1 is running on all of those replicas. If any errors happen, of course, you'd see an error in there. Now I'm going to actually change my deployment to replace v1 with v2. All right, so I've reconfigured my deployment, and what you see over here is v2 is starting to roll out, and as you see in the URLs there, we're switching back and forth between v1 and v2. So there's this rolling deployment of my application going throughout the system. No errors happening as I do this. So I could be under live user load, switching from version 1 to version 2, without any user noticing that this is even happening. But let's say, and now here I'm fully out in version 2. Let's say, for example, but it turns out version 2 was something that I didn't want. Normally, something like a rollback, especially in an imperative system, might be a really dramatic action. But in fact, rolling back is just another command line to say, let's undo that deployment that we just did. And what you're going to see here is we're going to start rolling back v2 is already dropping. The number of replicas is already dropping. The number of v1 replicas is already coming back. If you look in the display that's happening there, I'm flipping back v1, 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 v1. I've got one last replica of v1 to go, and there it goes. And I've rolled back to v1. Right? So in the span of a minute and a half, I've rolled out version 1 of an application. I've put it under load. I've rolled out version 2, no errors. Rolled back to version 1, still no errors. The user has no idea that anything actually happened under the surface. And I think this shows you the power of decoupling yourself so that you're focusing on your application and you have APIs that support the things that you care about in your application as opposed to the APIs for just your bare infrastructure like virtual machines. All right, so we'll kill that. All right, drop back to the presentation. All right, but really, honestly, this is still too hard, right? And this is where we're going to say, we're going to take a look at how orchestration can be the foundation for new platforms, right? And so I have this Kubernetes cluster, but now what do I tell my developers, right? You may have developers who are interested in containers. Some of them may have even been interested in Docker. But you can't force people as a prerequisite to getting their job done, to deploying their system for you. You can't necessarily force them to learn all of this stuff. Or if you do, you're going to either restrict the number of people who you can have, or you're going to put people through a bunch of training before they're even productive as developers. So to talk about how we're going to change this and really make it easier for developers to get started with containers and Kubernetes, Gabe is going to talk about a new project that we have. It's a little bit of a preview of a system called Draft. All right.
Get me flipped over here.
Yeah, I'll get you over there. That's there you go.
Hi, everyone. I'm Gabe. I'm the lead on the PM on the ACS team, and I'm going to show you a little sneak preview of a tool we have currently called Draft. And so, as Brennan mentioned, a lot of the focus on container orchestration to date has been around making the operations process easier, right? And self-healing systems, scalability, reliability, that sort of thing. And one of the problems that we see is that containers in the wild, they look too hard for developers to get going. There's a lot of conceptual overhead involved. I'd like to see a show of hands. Anyone here feel similarly? Do people feel like containers are too hard for average developers to use? Lot of hands in the audience. Okay, so you might be interested in what I'm about to show you. So what I have here is a very, very simple application. I have basically a Python app, very simple Flask app. And I want to make a couple points. I'm not running Docker on my laptop. There is no Docker file. I'm not running Kubernetes. I'm not running anything like that. No container overhead, conceptual overhead, or otherwise. But what we're going to do is we're going to actually make this developer here. I'm going to put my developer hat on. We're going to actually make this software target a Kubernetes cluster, start hacking away on that cluster, and then when we're done, we can commit that to source control and have CI take over. So how this works is pretty straightforward. I'm going to run draft create. It is going to detect that a Python application was in my current working directory, and it's going to actually scaffold out a number of things: a Docker file, a Helm chart, which we'll talk a little bit, I believe the GitLab folks will hit a little bit here in a minute. And then after that, it's pretty straightforward. I'm going to run draft up. And what draft up is going to do is going to ship my source code from my laptop up to the ACS cluster that's running right now. And it is going to build the Docker image on the cluster, render out a version of that application, and then go into what's called a watch loop, waiting for changes that are going to happen in the editor or IDE. So the developer can have a really, really tight feedback loop as they're building their application, but they can also run this stuff in the cloud where they're going to have access to all their production dependencies, all the cloud services they depend on, all the other stuff that may be deployed inside that cluster. So if we wait a minute here, we can see that we are currently building this Python application. You'll notice, thanks to Docker image layer caching, we'll only have to do a lot of this the first time. After that, it's going to be the layers will be cached, and this feedback loop will be much, much quicker. So you see this is actually currently pushing the image off to an ACR cluster. which is co-located with the ACS cluster in the same region.
Time
Come
always
on.
seems longer in demos, right?
Sorry, what was that?
Scroll up to see
Scroll up to see the command again.
draft up.
So the command was simply draft up. And what this is going to do is, again, it's going to ship the source code up to the cluster, build the images and artifacts in the cluster, and go from there. And we may have some demo carnage here live. Why don't we go ahead and break out and retry it? Let's see if that works. Maybe a Wi-Fi problem. Well, that was fast. Still waiting here. Retrying. Looks like we got a little bit of an issue here. So what I'm going to do instead is I'm going to actually show you an animated GIF version of this. How's that? All right, so what we're going to do here is the same thing. So we're going to take a look at the Python Flask application. We're going to run the draft create, which is going to scaffold this thing out. We're going to run the draft up. Actually, I can see in the background. All right, well, it actually worked.
Yeah,
so back to the live demo.
It was worried that you were ignoring it.
It was, yeah. It didn't like playing second fiddle. So what we can do now is we can actually curl this thing, and what we can see here, I think we might have some Wi-Fi difficulty. All right, well, flipping back to this. All right, so again, Python application, we're going to take a look at the app.py. Draft create is going to scaffold out the necessary components here. Draft up is going to be the single command that you're going to run to sort of kick off this inner loop interactive process here. And once that is fully running, the application is going to be served up by the ACS cluster at a given URL. And the developer is going to be able to hit this URL and sort of work on their application live in the cluster environment where they have full access to their production dependencies. From that point, any changes that they make to their application, the draft tool is going to detect those changes on the local file system, re-render re-push the source code up to the cluster, re-render a new release of that application, and you're going to be able to see that live here. Here we're going to go ahead and make a change. We're going to change this from hello draft over to hello Azure. We're going to hit save. And what you're going to see here is that the draft tool automatically picks up the change, rebuilds the Docker file, re-pushes the application, and helps the developer get streamlined. So again, in sum here, the developer did not have to install Docker, did not have to install Kubernetes, 2 commands, and they're actively running and working their development on a remote ACS cluster. So pretty powerful stuff. All right. That's it. Thanks, folks.
All right, cool. Thank you. And I think, so hopefully what this shows you is the power of the container orchestration system as the new foundation for new development experiences, right? We aren't assuming any knowledge of virtual machines. We aren't assuming any knowledge of anything except for that I can take source code, I can turn it into a package, I can deploy that package to a running system, and I'm taking advantage of those deployment APIs, in fact, that you just saw in the first demo to actually deploy that new code that you saw in the draft demo. So I really think that one of the transitions that we're having is that it used to be that a development experience was kind of a monolithic choice. You chose a development experience, and it dictated total control all the way down to your actual infrastructure. And I think what we're seeing here is that there's this division of labor evolving where the container orchestrator is taking over managing individual VMs. It's providing this application-oriented API, and then there's a variety of different applications that are taking advantage of that application-oriented API to provide even richer experiences on top. I mentioned Gabe came over from our acquisition of Deis. One of the things that I'm most excited about from that acquisition is this open source project that they're working on in conjunction with the Kubernetes community, contributors from Red Hat, from other companies around, and it's a system called Helm. And what Helm is really trying to do is to take that container orchestration layer, and instead of providing a developer-oriented experience, it's really trying to provide kind of an ops and application-oriented experience where I have a piece of software that I'd like to deploy, but I don't really necessarily want to understand the details of it. I just want to kind of double-click and have it work. All right, so I'm going to show you a little demo of Helm right now. All right, I am number 8, I think. All right, cool. All right, so here's Helm. Helm itself actually is installed as an application that runs on the Kubernetes cluster. Right? So one of the things that I was mentioning earlier that we continue to see is that this cluster that you turn up isn't just a cluster for deploying your applications. It actually ends up also being a utility place where you can deploy the tools that help make it easier for you to deploy your applications. All right, so Helm is here. I have this Helm command. I can actually use Helm to search for packages. So if you're familiar with NuGet or apt or any package manager that you've ever used on an individual machine, Helm is a package manager for your cluster. Right? So I can actually say Helm search MySQL. Right? And there are 4 charts that are available out on GitHub, all community supplied, community sourced. We have a stable channel, an unstable channel, a beta channel that you can opt into to find packages that you're interested in. Well, I'm interested in deploying MySQL right now, so I'm actually going to just say Helm install stable/MySQL. Again, should be very familiar to people who are used to installing something using apt. And what you can see here is it's telling me, oh, you know what? I just did a bunch of work. I deployed a bunch of Kubernetes resources. And by the way, if you want to get your root password, I generated a root password for you. Here's the command that you need to use to get your root password. Right? So a lot of times when you deploy software, it's a nice double click, but at the end of the day, you spend a lot of time configuring it. Right? One of the goals with Helm is actually to provide you with the ability to configure things, or simply have them be deployed in a secure by default manner. So they really are operational applications at the end of the day, not just a toy example that you happen to have turned up. All right, so let's see what we created out here. We created a persistent volume. So in Kubernetes, we have this notion of a persistent volume. One of the things that people say about containers often is that, oh, yes, they're for stateless applications. And while they're very good for stateless applications, they really can be used for any application, including a MySQL database. You can use these persistent volumes that are backed with Azure Disk to mount your storage into a container on one machine. If that machine fails, the container moves somewhere else. The volume moves with it. Likewise, we've deployed a container itself. They're called pods inside of Kubernetes. So there's the MySQL container that is in the middle of being created. And we've also deployed a service. And a service is a load balancer, a name that you can use. So you don't have to remember some IP address. You can just connect to MySQL inside of a cluster, and it will do the right things to route the network traffic to that container that we just deployed. So hopefully that gives you a sense for how we can step beyond the container orchestrator layer. Draft showed you how you get started as a developer. Helm shows you how you can get started as an application owner. But of course, throughout all of this, switching back to my PowerPoint, throughout all of this, you have to have an application management. You have to, at the end of the day, you're going to move beyond one developer on one machine pushing up a bunch of code. You need to step into a system that knows how to take your code, multiple developers committing to a source code repository, and take it out to a complete production deployment. And in that kind of environment, you're going to use a CI/CD, continuous integration and continuous delivery system. I'm really excited to have Job from GitLab, who's going to show us how they run the GitLab software on top of Azure Container Service. I will switch for you. I could tell you to. You press the 7 button.
I pressed the 7 button.
But I already did, so you're good.
Who is familiar with GitLab, what we do? It's quite a few. So in GitLab, you have your repositories. Your Git repositories, as the name implies. But what we did is in the same tool, we built CI, continuous integration, and continuous deployment. And we've had this for a while, and Kubernetes came along, and we saw, wow, this is so cool. There's so much we can do with it. So today I'm going to, if Wi-Fi holds up, I'm going to give you a demonstration of what the kind of stuff is that you can do right now with everything that is live with GitLab and Kubernetes. So what you're looking at is my GitLab instance, and it's actually deployed on Azure Container Service with the Helm chart. So all you needed to set up exactly what I have here is only 2 commands. Those 2 commands, they run, and when they're done, you can sign into your GitLab instance. And what I'm going to do is I'm just going to start a new project, and I'm going to import a very simple Ruby application. I have here. I'm going to make it public. Let's call this a cool app. There we go. All right, so I'm importing now a very simple application, and what I'm going to do is I'm going to go all the way from having nothing, right? We just have a bit of code, to having a full CI/CD pipeline with a staging environment, with a production environment, and even some other cool stuff. And just to show you, this is what it does. This is the entire app. It just says hello world, and then there's a little Docker file here which exposes the port, so we can actually see the hello world appearing there. So this is all I have. And GitLab is running on Kubernetes, and that gives me the ability to say, I want to set up auto-deploy. And here I select the template for our CI. So this is where we define how GitLab CI picks up whatever is in this project and whatever it does with it. And I only have to change one thing here. I have to say where Kubernetes lives, which is Azure. If I mistype here, it's going to fail. It will be hilarious. And I'm going to push this straight to master. All right, so the only thing I did is I added this simple file, which defines how CI runs. And this is also, for instance, where you can say, I want to run a particular test here. I want to do this and that. And in this case, what I did is I point to a particular Docker image, Kubernetes deploy. And what happens is that immediately GitLab kicks off what we call a pipeline. And a pipeline is just a number of steps of continuous integration. And we see that already build ran, and we can have a look what happened exactly here. And so what happened here is that because GitLab runs on Kubernetes, we spun up a container, we ran the code for this particular step, and then once it was done, we broke it down again. And now we're doing the same for a step that we call staging. And if I refresh, we'll probably see that the Wi-Fi is down. There we go. So staging is done. And that means we can go to environments, and we see here, OK, we deployed, and we can actually have a look and see if it works. It's small, but it says hello world. Great. So the only thing I did is I imported my application. I said, let's auto-deploy this, and GitLab helped me set up a staging environment. And because you don't always want to deploy immediately to production, we made that a manual step, as we called it. So I can go here, and I can say, I'm happy with this, play, and it will start to deploy to production. Now, this is cool, but what are the things, like we have this auto-scaling CI. What are other things we can do? What if we could preview whatever we are working on? We have that power now. So let's make a change and see what happens if we can get a live preview of the change. So I'm just going to change the file here, and I'm going to say hello build. And this time, I'm not going to commit it straight to master, which I hope you're all not doing. Build. I'll just build. I'm making this change, and I'm telling GitLab immediately create a new merge request, or maybe you call it a pull request, but it's not the correct term. All right, that looks good. And you can see here the change that I made. I just changed the word world into build. And what you see here is the same thing happening, right? So we have, again, this build step that gets started here. But now we're starting to do something cool, and then we'll just have to be patient with it. Rather than saying, we're deploying now to staging, this is a change that has not been approved yet, right? We still have to review this. So what we do here is we create what we call a review app. So that's a dynamic environment that GitLab created on Kubernetes just to preview the changes that are here. Meaning, this is not live, this is not in staging, yet we still want to be able to see how this is looking when it is eventually deployed in production. Rather than just looking at the code, I now have a URL here that if I click on it, hopefully it will say, hello build. There we go, hello build. All right, so if I'm happy with these changes, I can accept a merge request. GitLab will kick off another pipeline, and it will do the same thing as it did before. It will deploy to staging and wait for me to say, OK, deploy this to production. But considering we are running on Kubernetes, and considering we have all this application running on Kubernetes, we can do other cool things because we're so close to the application. So the last thing I want to show you is that, and this is something we recently introduced, is that besides having the ability to spin up dynamic environments, to break them down, because I pressed merge, and what GitLab does, it breaks the environment down now. Besides that, I actually have monitoring right here. So I can see exactly the changes that I made, how they affect the state of my containers that are running in staging, in production, or any other environment. And that's all I wanted to show to you today. Thank you.
Thanks so much. Oops, PowerPoint, not my demos. There we go. All right, thank you so much. And I think that's really a nice demonstration, again, of what happens when you've decoupled yourself from infrastructure, when you've built that container-oriented foundation, and then you start seeing the applications, the rich applications that you can build by the fact that they're sharing and assuming the power of the container orchestrator that runs below. All right, so what the last thing that I wanted to give you here before we finish up is some glimpses of where I think we're going. Where I really think that, because I think we're only in the beginnings of how containers and container orchestration are transforming the cloud and how you deploy applications. And the rocket ship is heading right for the comet. So one of the things I wanted to show is this notion that distributed systems are becoming more modular. It used to be that, and still is in many cases, that a distributed system is a bespoke system. It's this very handcrafted, artisanal, mostly they come from Portland, I think. Is that, no. They're these artisanal sort of things that you put together, and people who do it, they're craftspeople, right? And I think that's great, and it's a really fun craft to have. But ultimately, if we want to make this something that everybody does on a daily basis, that people do in middle school, in a computer lab, we have to democratize how you build distributed systems. And one of the ways that we do that is by making these things more modular so that I can adopt other tools, right? Nobody builds GUIs anymore. We rely on the operating system supplied GUIs, and we manipulate how the buttons go together. 20, 30 years ago, people drew pixels to make buttons appear, right? We always are doing this process of taking things that we used to write, making them modular and reusable. And in particular, I want to show the system called kubelego that runs, again, on top of Kubernetes. It's actually an integration with Kubernetes and Let's Encrypt. So deploying and managing certificates is painful for most people. Let's Encrypt tries to make that easier, but honestly, it's still a little bit too hard, right? And so what kubelego does is it pays attention to your HTTP service. It sees that you would like a certificate. It delivers that certificate to the HTTP service, and you're off to the races. And by the way, it renews it as well, right? So with this simple daemon that's up there running in your environment, again, deployed to your cluster orchestration environment, not to any particular application, you can produce arbitrary certificates for any HTTP service that you happen to deploy into that system. All right, so to show you this, I want to give you a little bit of a demo of this in action. And I promise this is the last demo, assuming my computer wakes up. All right, you guys can guess my password again. Of course, I disconnected. All right. All right, so I'm again using Helm, and I'm taking a look at the Cube Lego chart, the Cube Lego application that's there. And what you'll see is it's actually described a bunch of different configuration options that I have. In particular, I can choose between the production Let's Encrypt environment or the staging Let's Encrypt environment. I'm going to now show, I have this thing up there. I'm trying to curl to this HTTPS endpoint of an application that I've displayed. What you can see here is curl is saying, hey, you know what, your certificate validation failed, verification failed, because I used a self-signed cert. Curl doesn't like that by default. All right, so now I'm going to say, OK, here's my configuration for Let's Encrypt. Let's install the Let's Encrypt chart. Now Let's Encrypt is up and running. All right, now I'm going to take that service that I have, and I want you to look right here. You don't need to pay too much attention to the rest of the details, but right here I've added this one annotation to my service that says, hey, you know what? I want there to be a Let's Encrypt cert associated with the service. And down here I have this TLS section that describes what's the host that I want that cert for. Now the Lego service that's up there running in my Kubernetes cluster is watching all of these services. It sees that annotation. It knows that it's supposed to be adding a certificate for it. And it's actually doing it in the background for me. So by lighting up this one annotation, this modular system that I didn't build, that I imported from a third party who had built it for me, is starting to do this work on my behalf. So now I'm going to apply that description. It's been updated. And now we're going to just watch. And so what you can see here is it's still insecure. It's retrying every 2 seconds. Keep our fingers crossed that this will work. And there you go. Right? So now I'm seeing it's the Nginx page. It's a default Nginx install. But I went from having an insecure self-signed certificate to a well-known recognized certificate by adding one line of YAML to my declaration, simply because I had this modular piece installed. Right? And I think that really shows the power of what happens if we decouple our systems, if we build reusable modular systems that we can compose together. And I really think that is the future of how we're going to build these new development environments. All right, and so that's about it. I see that I have 7 minutes left, and so at this point I wanted to throw it open to the audience for any questions or anything else that you might have for us on containers or anything else. Yeah, and there's a microphone, so if you don't mind for recording and for everybody else, if you would line up behind the microphone if you have questions. There's one in various places in the hallway. So
I have just one question. So container services cluster, and then there's Azure Service Fabric and Service Fabric cluster.
Right.
So how does they relate? Is Service Fabric support containers, or
yeah? So Service Fabric is a Service Fabric. If you see in that diagram where you saw container orchestration, Service Fabric is a container orchestrator, just like Kubernetes or anything else like that. Yeah. It also has a richer environment for building applications as well. So it combines the ability to deploy containers with a richer programming environment that you can opt into as well. So that's how it works. Any other questions? Yeah.
Hi, Brendan.
Hey.
Back here in the back. Hey. I'm fairly new to containerization, and my company right now is trying to make decisions about which direction to go. We're considering Kubernetes, we're considering Mesos, we're considering Service Fabric. I haven't seen a lot of guidance in the area of when would you want to choose one technology over another with that, and I was wondering if you could offer your opinion.
I think really it's going to end up being kind of I'm not going to make it easy for you, I guess. It's going to be really an individual choice. I think it's kind of like saying, do you choose SQL Server or Postgres or MySQL? There's different advantages and disadvantages to each. I'm pretty deeply involved in the Kubernetes ecosystem and the Kubernetes community. I think it's a really strong open source community that you can run it from Raspberry Pis all the way up through 5,000 nodes in the cloud. I think that's pretty cool. But there's advantages to all of the different platforms. So,
okay.
Sorry.
Do you know if the Azure Container Services group will be providing any guidance on how to base the choice of container orchestration?
I think that we always are trying to put together profiles of applications that fit best for people. So it depends on the specifics of the application that you're building, but I'm happy to chat about that afterwards.
Thank you.
Yeah.
Hi.
Hi. Oh, sorry.
Hey.
Too many lines.
So a question on the persistent volumes.
Sure.
So you had done MySQL.
Right.
How does that work if you want to scale? Does it have to be aware of that persistent volume to be able to scale and not obviously right over each other? Locking issues and such?
When you have scalable solutions, so MySQL by itself isn't really a very scalable application, but like if you notice in the chart, there's a Percona install, which has some clustering, or Cassandra or Mongo. In those worlds, each container has its own volume, and then there's application level data replication, right? Like even if you run a clustered MySQL, they don't all write to the same database. They write to 3 different databases and 3 different file systems. And so the same thing is true with the persistent volume. Now, if you deploy something like WordPress, you might deploy an SMB file share where it's actually shared across multiple applications, and that works too. But the application then is managing the fact that multiple people could be reading and writing from this thing at once. So,
Right.
Yeah.
Excellent.
Cool. Thanks. Yeah, back there.
So very generic question on containerization. So in my understanding, containerization occupies space somewhere in between IIS and PaaS, right?
Yeah,
Kind
I
of.
think it's accurate.
So essentially, if your application can be deployed on PaaS, it doesn't really make sense to containerize it, or does it?
Well, I guess what I would say is I think that what we're seeing is that new generations of PaaS are being built on top of containers and being built on top of container orchestration. So as you saw with Draft, a developer might not even know that they're using a container, but there's a container in there somewhere. And there's a couple different reasons for that. One is so that the PaaS can take advantage of the container orchestration layer. And then the other is because oftentimes PaaS is great until the moment that it's not. And when it's not, it's this cliff, right? And so I often say that one of the reasons we're seeing these next generation PaaS platforms built on top of containers is because when you have to hit that escape hatch, it's much more like firing the gardener than it is like jumping out of a plane without a parachute, right? So your grass gets a little longer each week, but it's sort of survivable, and eventually you learn how to mow the grass. It's not like falling 35,000 feet and having to sort of rebuild everything on the fly before you hit the ground. And I think, again, so I think you may not, from a developer perspective, want to know about or learn about or use containers, but somewhere in the stack they're going to get used. So, and I think different pieces of your application also may find different places, right? Some places will fit really well in a PaaS stack. Some other bits you may really want to containerize and run as a container. So,
Thank you.
yeah.
When you use Azure Container Service to deploy a cluster, you choose your orchestration model or framework. It's always been Linux, and then Kubernetes just got Windows support on the
Right.
nodes. Is there any vision or roadmap or anything for like mixed nodes, like Windows and Linux nodes to be?
So actually, right now in the open source, we have this thing called ACS Engine, which is the open source core of the ACS product, where we sort of experiment and develop with, we almost call it the ACS Labs. It's sort of where we experiment with new features. You can actually use that tool to deploy hybrid containers. And so that's coming to ACS in the near future, that ability to have, not just, honestly, not just hybrid containers Windows Linux, but hybrid clusters Windows Linux, but also hybrid clusters. Maybe some have the SSD and some have a lot of memory or whatever kind of GPU or other kinds of things that you might want to have in a heterogeneous cluster. So that's definitely coming. Yeah. Yeah. The stance when it comes to bare metal containers, if you want to run in a bare metal environment and you want to plug machines in and out, they work really great. I mean, I don't have a, like, I'm not sure I have a stance, I guess. I think there's a lot of advantages to being in the cloud, but Kubernetes runs great on bare metal. I have a Raspberry Pi stack at home that I play around with. That's a lot of fun to play around with. I'm too cheap to build a bigger cluster, but someday maybe. Yeah.
Hi. So in the demo that you showed Lego,
Yeah.
who is the certificate generation authority over here?
It's a service called Let's Encrypt. I don't know if you've ever seen Let's Encrypt before.
Yes, but is it generated by the ACS?
No, so Let's Encrypt actually is a CA root. So
Okay.
they actually hold the certificate authority root. And then they've defined a protocol that they call ACME for how you do a secure exchange with them to bootstrap and verify that you actually own the domain. So what's going on when you do that behind the scenes, actually, is that KubeLego is deploying very briefly deploying a service with a key. It actually obtains a key from Let's Encrypt first, and then it deploys a service with that key. Let's Encrypt checks in over the domain name to find that you know that you have the key, which establishes that you own the domain, and then they issue you a cert for that domain. So you can read about Let's Encrypt. It's more complicated than I should explain here, but it's a well-known service for doing this.
Okay.
Down here?
And what is the scale?
Sorry?
What is the scale of containers that you would run on a platform, for example?
It's dependent on the number of machines. You can scale up to thousands of machines and hundreds of thousands of containers.
No, on a single platform, would you run thousands of
When you say
containers?
single platform, do you mean a single machine, or do you mean a single
Yeah, a
container
physical
orchestrator?
machine.
On a really beefy, on a 32-core machine, you can run in the hundreds. So,
Okay, thank you.
Or more, depending on how active they are. One more back there.
Yeah, I'm fairly new to container orchestration and Kubernetes.
Sorry, I can't quite-
I'm fairly new to container orchestration and Kubernetes and so on. I was wondering, when you update a version of an application, does the orchestrator take care of session draining, or is that something you would need to manage through a load balancer or something like that?
Yeah, no, the Kubernetes framework has two concepts that help with that. One is it has a notion of a graceful termination, where it will take you out of a load balancer and then wait 30 seconds by default, but configurable before it actually terminates you. So that allows you to drain the connections on the outside. And then on the inside, it has a notion of readiness, which means it won't add you to the load balancer until you affirmatively say, hey, I'm ready to serve live traffic. And so that's how you can achieve that rolling update without dropping any packets. It's those two combination of those two features. Yeah. All right, I think I'm pretty much out of time. We're happy to hang out and answer questions not in this environment, but thank you so much for coming. I hope it was interesting. Thanks.